Hi grade 4s. Today we're going to be looking at bevel, worm, and rack and pinion gears. All three of these types of gears allow us to change direction. Bevel gears are two gears that are connected at a 90-degree angle. They are often cone-shaped to allow the two gears to fit better together. They are used when the direction of a shaft's rotation needs to be changed. Think of it like changing direction from going across the floor to climbing up the wall. Unlike spur gears, which are often on the same flat surface, bevel gears are usually perpendicular to each other. That means they are at a 90-degree angle. This changes the direction of rotation from one plane, like the floor, to another, like the wall. Think of an electric drill. When we push the trigger, a bevel gear allows the drill bit to turn perpendicular to the direction of the trigger's gears. The gear ratio works the same way as spur gears, which means that we divide the larger number of gear teeth by the smaller number on the smaller gear. Watch the video below to see a bevel gear in action. You'll notice that as the gear on the left rotates counterclockwise, the gear at the bottom turns clockwise, however it's on a different plane. Think of this like your wall and this like the floor. Worm gears also transfer motion perpendicularly. In this case, a worm is meshed with a wheel called a worm wheel. The worm gear acts like gears with one very long tooth. This allows worm gears to produce high torque or power. Worm gears transmit rotations in perpendicular directions, similar to the bevel gears. They are usually used as locking mechanisms because rotation can be transferred from the worm to the worm gear, but not the other way around. That means that the worm can be used to turn the worm gear, but the worm gear cannot be used to turn the worm. The gear ratio is always 1 to the number of teeth in the worm wheel, which means because the worm has only one tooth, it's 1 to however many teeth are in the worm wheel. If the worm wheel has 30 teeth, that means that our gear ratio is 1 to 30. This is what gives us a lot more torque. For every one turn of the worm wheel would turn 30 times. Guitars and banjos have worm gears at the end to tune them. The ability to transmit a lot of power and to not go into the reverse direction makes them very helpful in elevators as well. They can only go in one direction, which can be used as an emergency stop to prevent the elevator from dropping. They can also be used in large gates. Because the drive can only move in one direction, the doors cannot be forced open. They would have one worm gear to open them and a separate worm gear to close them. You can see examples of these in our photographs on the right. The top photo shows an example of a worm gear in an elevator, and the bottom photo shows an example of a worm gear that would be used to open or close a gate. Let's watch another video of what worm gears look like in action. In this case, you'll notice that as the worm, the part on the top, rotates, each tooth will mesh with one of the teeth on the bottom gear. A motor can be used to rotate the worm, which then turns the gear. Let's watch another video to see an explanation of how worm gears could be shown with Lego.
If you take a look at this gear arrangement here, hopefully you're going to recognise this. This is called a worm, and then this part is called a worm wheel, sometimes called a spur gear. However, it should be cut slightly different from a spur gear, but I'm not so sure whether it is in Lego. Anyway, we can turn this part so we could regard this as the input and then this as the output. And you'll notice that the input is going to be running at 90 degrees to the output. The other thing that you'll notice is that the input, is turning much faster than the output. And the relationship is that this is going to turn in this case 28 times for every one rotation of this. Now, the way I worked that out was I counted the number of teeth, which is 28, and I happen to know that with a worm we only have one tooth. Now, that sort of probably doesn't make a lot of sense why you think this only has one tooth, but I've marked the spindle here, so I've marked that red with a pen there, and I've also marked this one as well, so hopefully you can see that there. Now let's see what happens when I rotate this by just one rotation. Did you notice that this tooth only, or this gear only advanced by one tooth? Let's do it again. And once again, it's only advanced by one tooth. Another place you might want to look at, if you look at the grid here, and you see that it's in alignment, let's rotate now by just one. And hopefully again you saw that it's effectively advanced by one tooth, not that it really has teeth. So when we're working out velocity ratio, we normally do the...
So the main message that I'd like you to gain from this video is that for every single turn of the worm gear only turned by one tooth. So again, in that situation where we had 28 teeth on the gear and one on the worm, for every 28 turns of the worm, this gear would make one full rotation. So the gear ratio would be 1 to 28. The final type of gears that we're going to look at today are rack and pinion gears. These also convert rotational motion into linear motion. The circular gear is the pinion, so that's this piece here, and the linear gear, or this flat piece, is the rack. Think of it as if it was a bevel gear, only the bevel gear has been unwound, so we took the circle and folded it out into one flat surface. A perfect example of a rack and pinion is the steering system on many cars. The steering wheel rotates a gear, which engages the rack. As the gear turns, it slides the rack either to the right or the left. So if you were to turn left, it would cause your car's tire wheels to rotate and allow you to turn. Here's a video to show what that looks like in action. So in this case, the steering wheel is turning to the left. Now we're looking from a different angle. So in order for the car to turn left, the gear wheel turns to the left and moves the wheels. To turn clockwise, or for example, if you were trying to make a right-hand turn, again you'll see that the gear turns clockwise, causing the tires to turn to the right. That's the end of our video for today. Please take a look at the handout that I've assigned for you